I've had several requests from people who had built ADXs asking if it was possible to operate it on 160 meters. In this video, I'm going to demonstrate the operation of the ADX on the 160 meter band. Now, in order to achieve that, a new version of the firmware has been downloaded, which provides for 8 bands, and the regular 10, 15, 20 and 40, 17, 30 and 80, and now the 160 meter bands. Now, in order to operate the ADX on the 160 meter band, you need to simply go in and change in band configuration mode using the standard process. So you can see here we're currently on FT8, and if I select band selection mode, you can see the 40 meter band was flashing over here. The way this nomenclature works here is the bottom line is 1 LED, the second line is 2 LEDs, and now the third line is 3 LEDs. So currently configured for 40 meters. Now if I scroll through the bands, 40, 20, 15, 10, we then go up to 80, 30 and 17. Obviously the 2 LEDs corresponding with the 17 here on the second line. If we go one further, we now have 3 lights illuminated on the 160 meter band. So if I lock that away, and 3 flashes there indicates that it's now stored and operational on the 160 meter band. Now you do need a low pass filter, and the specifications for that are shown on the screen now. Now I've wound that filter sitting here at the back, fairly tight to do that. You can see that the windings there on some of those toroids are quite solid. Now the winding on L2 is quite tight. You'll get about 21 turns going around the toroid on the first pass, but then to get to 33, you just continue to wind over the top of the first layer until you achieve the 33 turns. But nevertheless, it works effectively. Just fit that back into the ADX. And the one other thing to point out, now that we're in 160 meters, there is no published frequency for FT4. So what I've done in the firmware is I've eliminated the ability to configure FT4. So now you can only operate on FT8. If you press again, it would normally have taken it to the FT4 slot, but I'm still defaulting and holding it in FT8. One more press, you can go to GS8, and then to Whisper, both those operating modes are available. But if you come back, we'll try to go to FT4, and it takes us straight to FT8, and FT8 is effectively operating on or allocated to 2 of those slots. So right now, we're currently on FT8 on the 160 meter band, and if I turn the power off and start it again, you'll now see we have 3 lights flashing indicating that we're on the 160 meter band. Now just showing you the setup that I'm going to use to demonstrate the ADX on 160 meters. I've got the ADX configured to operate on FT8 on the 160 meters. That's connected through to the barber watt, so we can see the amount of power that's going out. That then goes through into the spectrum analyzer through an attenuator here, so that we can look at the harmonic suppression. I've also got the ADX being powered by the power supply over there, so we'll be able to see how much power is being drawn on transmit. And whilst there's no direct connection to the antenna, there's sufficient radiation that my external antenna will actually pick up the ADX transmitting through into the spectrum analyzer. And what we're looking for here on FT8 at 184, the center of the upper sideband, the 0 point there is a 1500 hertz signal on FT8. So as we're putting the base carrier through when we hit transmit, we should be seeing a signal appear at negative 1.5 kilohertz from the bottom end of the sideband spread that's being displayed there on the IC 7300. So coming back across here then, so we'll just simply press the button here, power down, and we'll see we've got about 2.7, 2.8 watts there. We're drawing around 438 milliamps, and as coming back through here, 2.8 watts. You can also see there, as I said, I'll just stop transmitting and come back on again. You can see the signal being picked up there at negative 1.5 kilohertz at the bottom end of the USB envelope for 160 meters, so it's working fine. But let's come across and have a look at the harmonic performance. You can see here the fundamental at 1.84 is sitting at 3.5 dB, and the second harmonic is suppressed by 40.5 dB there at the moment. So we've got over 43 dB suppression on that second harmonic. You can see the third, fourth and fifth harmonics out there on to the right. So well and truly within legal requirements in terms of harmonic suppression from the ADX. So you can see here I've kept it coming down. Things have warmed up a little bit. We're now up to 3 watts output, and 465 milliamps draw is taking place at that point in time. So I haven't attempted to tune the low pass filter that's in the ADX at this stage for optimizing its efficiency. Clearly a little bit of work that we can do there, but I do have the output from the VNA looking at the performance of the filter, and we'll take a look at that now. I've mounted the VNA in a test jig that I built, and that's connected through to the VNA in order to measure the filter performance. This is a sweep from 1.75 through to 10 megahertz, and you can see the deep notch that's occurring around the 3.8 megahertz mark, which is suppressing the second harmonic. Now if we go on and zoom that in a little bit closer and look at a sweep from 1.75 to 4, the depth of that notch is quite evident, and it's showing down at around 55 dB suppression. And for those that like looking at Smith charts, this is the Smith chart of the LPF on a 1.75 through to 4 megahertz span. So there you have it, an ADX capable of operating on 8 bands, including 160 meters, with good demonstrated harmonic suppression. So all the reasons to try and make a successful operation with QRP down on 160 meters. And if you need the firmware and the documentation, that's available from my GitHub site. Good luck with the project, and 73s.